In the class, we were mostly doing like pretty much hands-on, um, giving people tasks and helping them out on solving them. So yeah, so hence the amount of stuff, the new stuff which has been introduced is actually like kind of little, which is normal in this case, because Priii 3 is more like a hands-on class more than a very theoretically heavy class. So I would like actually to show you, I would like to talk about interfaces before I carry on with this, because there are a couple of things I would like to add on top of what Dennis already have mentioned. So I will actually like create maybe, let's see. So maybe this I will actually like raise for now, or just keep it like in a function somewhere. So I will just maybe move this to somewhere like planet. Yes. And then I'll just simply keep it here. Point. And I'll just simply collapse it because I don't care much about it. Because I would like actually to talk about the how we would utilize an interface and stuff like that. Maybe I will even attach. I will like compress this project and put it on to if you want to, but the code is actually very primitive here. So interfaces by default. I mean by definition. Sorry. Now, Dennis actually, when he talked about interfaces, he talked about them as, I'm actually trying to get, he talked about the iLogger, and he logs to a database or logs to a console and other things, iRepositories as well, right? And I just wanted to mention here that interface is one of the most important things, which he also said, I think, is interfaces are actually contracts, which is very important to understand. So an interface defines a contract. Any class or struct that implements that contract must provide an implementation of the members defined in the interface. And this is like one of the key things that you really need to like keep in mind when you are looking at interfaces. They are literally contracts. Now, the implication of such definition is big, and here's why. Because when people actually write code, when they define an interface, you have to really think about if actually a certain method which is actually inserted in there should be a part of that contract. So, for example, when Dennis actually defined iLogger, and this is the part which I would like to talk about, he had, for example, void log, right? And then you have a string message, for example, right? And then people use this iLogger and for example, you have log to database, let's say. So for example, people say having a class DB logger, which implements iLogger, and then you would like to implement that logger, right? Now the problem with this is that if somebody suddenly says, aha, okay, my DB logger does this, what if I actually like, and since the code is actually here, I can actually do interesting things. For example, like here, you're gonna actually say insert a log of activity here. So the code of log activity happens here. What will happen, what might happen, that somebody comes in and hijacks the code and he says, okay, I can actually have, and does this. For example, object customer, for example, something like that. And then your DB logger suddenly becomes responsible for inserting a customer, even though the logging itself doesn't have to do anything with inserting customers into a database, right? Now, this is actually a very key thing. Whenever you are actually in a dichotomy, whenever you are in like thinking, should actually a method be a part of an interface, you have to ask yourself, does everybody who implements that interface has to implement this function or this method? Should be part of everybody's contract. It is the same thing like when you are signing a contract in real life, and you are trying to say, for like you are actually a developer and everything, and then suddenly like in your contract of a developer in a company, for example, you are responsible for cleaning Windows, right? This right now, like, and every developer who signs this has to clean Windows as well. Now, this is actually a very interesting, like, of course, this is actually obvious. You cannot have, like an engineer who's working as a developer full time and he has to clean Windows, right? So you cannot actually have that. But in some cases, you get into a gray area where you really don't know whether a function should go into an interface or not. And if actually that happens, if you are happening to be in that gray zone, you have just simply like think about it for a second. If anybody else comes in and he has to sign the contract, do they have to implement that function? Are they supposed to do that or not? And based on that, right now you will realize how you design your interfaces. Now, this is actually one of the parts this is actually more like a software engineering like talk rather than the actual technical how you use interfaces, right? The decision itself, how you decide whether to use interfaces or not, and when and where and why. Okay, so now Dennis actually have covered with you the iLogger part, which every full stack developer probably will see, not only the loggers but everything, also other things, because people usually like to convert everything into contracts, which is actually quite useful and quite easy to work with. But for example, me as a game developer, I would like also to show you the other side, which can actually also show you the implications of what happens if you don't use interfaces, which also the reason why we use interfaces also in full stack development. I mean, in any development of sort. You will see exactly the same effect, except for instead of having interesting game objects, you will have customers and employees and bills and stuff like that. So you will have different naming, but you will see exactly the same pattern repeating. So, for example, let's say I'm trying to solve a problem of I'm having a game like GTA or not GTA, but any game like that has a lot of interactions with elements. So I can turn on lights, right? So you actually in a game you can walk in about and then you press a button, like you turn on the lights and turn off the lights. You could, let's say, you could, for example, pick up a chair. You could shoot a gun, right? All of these kinds of interactions that happens with a left mouse button click, by the way. So you have one thing to do, but you have many different interactions are happening based on the context of what you are interacting with, right? So for example, let's say I have a class called light, and I would like to have it turned on or off. So I would like to turn on or off the light. So I can have private Boolean is on, and then I can have, let's say, public void interact. And the moment I interact with the light, I just turn it on. And if it is off, I just turn it off. I mean, if it is off, I turn it on. If it's on, I turn it off. So I invert it. So I can say is on equals to not is on. So if it is on, it will be off. And if it is off, it will be on. So this is like kind of inversion, right? And for fun here, I can actually have a console, the write line, let's say here var light state equals to is on, then we're going to have on, and then else is going to be off, right? And right here I can have light is, and then I can have here light state. There we go. Okay. So right now I have that. So whenever I interact with the light, it will just simply turn on or off, depending. Obviously, when I initiate when I have a variable like this, Boolean by default, like when I make a variable, it will be false. So it should be true when I interact with it. But in any case, moving along. So we have a light to work with. Sometimes I would like to interact with the door, open the door or close the door. So for example, we have a class called door. And I can actually even copy this. And I'll just simply rename is open and is door opened or closed, right? Let's say you would like to have a chair. So class, a chair. And a chair, actually, when you click on it, it should be actually be able to be picked up. So I would like to have, for example, public void pickup. And here I'm going to have a console.writeLine pickup. By the way, working with interfaces here can actually help me out as well, how to define how the rendering will happen. Maybe, I mean, I shouldn't actually have here console WriteLine. Maybe I would like to have graphics, right? And you can use the interfaces to do that, but this is a little bit advanced. So I will actually just simply talk about how you can make this even better by just looking at this simple code. So light door, So, and the gun, you can actually pick up the gun. This is the part, this is the fun part. So public void pickup. And then you can have picked up the gun, for example. And then you have also shoot or interact. Because when you interact with the gun, you shoot it, for example. So console, at least in our logic here, light line, bam. There we go. Okay. Now here's the issue. Let's say I have a crazy superpower, and I would like actually to trigger all the interactions at once. Your problem, which you're going to run into, let's say you are forcing your way through. Okay. So let me actually collapse these guys. These guys are simple functions. So what you're going to do is actually you're going to have a list of objects, which is going to be list lst equals to new list of objects. And right there, I'm just going to add in my objects because the only common thing between them is their parent class, which is an object class. So I'm going to have here new light, new door, new chair, and then new gun. So I just simply instantiated objects directly and I inlined them within the list. So I added 4 objects inside the list. And if you would like to go even further, you can have here a var if you would like to make it shorter, which is pretty much the same. Okay. Now, let's say you have, for example, which we call the superpower, interact. So private static void interact with all. And right here you say for loop. We can actually use even for each if you want to, but for the time being, because for each hasn't been covered yet, we're gonna refrain from doing it right now. So an lst of I, actually, here I'm gonna send an object of an item, let's say. So here I'm gonna have interact with all, or actually, it shouldn't be interact with all, it should be just simply interact, I think. Because interact with all is a different way. Interaction, that would be so. It's a very bad function name, but I just want it to be different from the interfaces, which I would like to make later. And here I'm going to have lst of I, right? I'm sending the object. Please interact with every one of those in the list. Now, unfortunately, you never know what's happening, because if you say item dot, you cannot actually do anything of that. You need to cast it to every type. Now, casting is going to be interesting, because you're going to have to say if, for example, item is light, then you say item as light dot interact, right? This is actually what's going to happen. And right now you're going to have interesting stuff going on. So we're going to have if. Obviously, we're going to have the else's, so we don't actually check against everyone. So if one of them succeeds, then we are good to go. So right now, we have the light, we have a door, and door, and then we have a chair, and then a chair. Now, the chair actually doesn't have interact, it has pickup, right? So we say pickup, and then light, or right now it's going to be gun. We have gun. And gun has a shoot, actually. Or interact. Oh, sorry. There. And if I actually hit Control F5 for this guy, we get this running. But this is actually horrendous, obviously. Right now, what's going to happen is you're going to write, like, God forbid, if you have 100 different objects to interact with, and then you're going to have a kilometer long of if statements. This is a worthy of a Reddit coding horror post, to be honest. So what you usually should do in this case, you will understand that your interactions are actually common among classes. And even if you use inheritance, it will not be as good as using contracts. So because you're going to have to do casting and all of that other stuff. So in order to fix this, to make this better, excuse me, just give me a second. Right, excuse me, can you hear me now? Hello?
Yes, we do.
Oh, okay. So where were we? So yeah, so I was saying that we need to have the contract, which is interaction. So I'm gonna have interface I interactable, where we have a function called interact. So everybody who implements that contract, or everybody who signs that contract, you can actually be interacting with. Interface I pickable, because if void pick up, because for example, a chair can be interacted with, so I can throw it at an enemy, and I can pick it up as well, right? So we can have like two of them. So this is actually kind of cool. So right now, all what I need to do is make sure that the light, for example, implements the I interactable, for example. It cannot be picked up, so it will never be I pickable. And it's the same thing with I interactable. Here, I interactable. Now, I'm lucky that, or not lucky, or whatever, that I have actually the function is actually matching. If it was any other name, it would have complained, hey, please implement the contract. That's why it is, you see, it's even Visual Studio is highlighting it. A chair can be picked up, so it's I pickable, right? I can make it also, and you see it's right now, it's making a fuss because pick up is actually this, right? And I can make it I interactable, and then of course it will complain. So right now here, I can say console.writeLine throwing a chair at an enemy. So before I didn't have this ability, right now I can have it by just simply implement that interface and it's done, right? A gun can be also picked up and can be also interacted with. So I can just simply like, let me rename this to this, so I can satisfy the contract. And right now I will not have to make a casting or anything. All what I need to do is just simply say, give me everything that I can interact with, everything. So I interactable. And I'll just simply inject it there. By polymorphism, it will accept it. And right now, I don't need to do actually any of this stuff. Right now, I can just simply say dot interact. And that's it. Because I have a list of I interactables. So everybody who implements that contract can be here. So for everyone, I will call the function. So if I hit Control F5, right now it will work. Okay, so that's the basic idea. Now, some people, and it's also, and you will see it in production, I think more, making something which is called a marking interface, an interface that is the father of all interfaces. Usually something like this. So interface, for example, game object or I game object, right? For example, actually, I'm making things up right now, but in terms of an example, however, this is called a marking interface, that kind of look, okay? And it is actually frowned upon. People in software engineering don't like it that much. It is useful sometimes, but it's if you use it too much, that means that you have something wrong. So people have interfaces inherit from other interfaces, for example, like this. Okay, and right now all the interactables on iPickable are actually iGame objects, for example. Okay, this is a pattern in software design, and sometimes some people don't like them. I honestly don't have right now a good idea or a good use case for it here, but you will definitely see it in production. Some people do this just to generalize all other interfaces under one umbrella. To make like APIs easier to access and so on. So I'm not actually I'm just mentioning it here for FYI, so you guys know that this kind of pattern exists. Also, I want to mention that there is also a reason why this I exists before an interface name. So here, for example, interface I interactable, you're going to see later on when we teach for each loops and iterators, we're going to talk about I enumerables. So anything in C#, all interfaces in C# by standard, we usually have this, we prefix it with I. And there's a historical reason behind it, why we have it. For example, if you look at Java, in Java, you don't have I in there. So in Java, when they call the interface, they write in, for example, public interface, and then the name of the interface, they say, I don't know, interactable. They will never say I interactable. And I think as well, if you work in Android Kotlin as well, you're going to have the same thing because we all inherit from the same, they all inherit from the same concept, I think. So why we put I in there, right? What happened that we kept this I? Now, interfaces is actually a software engineering concept. I mean, right now it's a programming language construct, but it's actually a software engineering concept. And in C++ days, what people wanted to have, they wanted to have interfaces, but in C++ you don't have interface, you have only abstract classes. The fun part about this as well is that in C++ you are allowed to have multiple inheritance. In C# you don't. However, a C# class can have many interfaces, like here, as many as you want. In C++, you don't have interfaces, but you can have as many classes as you want. So what the people did was they actually took the abstract classes. For example, I'm actually gonna, I'm gonna actually call this, for example, like if you have actually, if you are writing this in C++, you would say I shootable, for example, that this thing can be shot with, right? And then here they have void abstract, void shoot. Now this has to be public, obviously. Now this pattern in C++, they actually said, this is how you write an interface. This is how you communicate to other team members. This is an interface. And this forbids you as a developer from having a public void something and then write the default code in there, right? So you shouldn't be having a default code within an interface. C# 8 or 9 right now, they have default interface implementations, which honestly I disagree totally with, but probably there are a lot of reasons why they have it, but I'm not going to discuss that. But generally speaking, in C++ days, they wanted to utilize abstract classes as contracts. So they just simply said, okay, from now on, if you would like to make a contract, it will be an abstract class, but just make it as an I in there, just to tell me that this is an interface. So when I work with it, I know that this is a contract and I need to obey the contract and treat it like a contract. C#, when it came out, they right now introduces the keyword interface. And as a result, they just simply, we inherited this I, we just simply prefix it with an I, and this is why we have an I in there all the time, even though we don't need to, because the programming language already tells you it's an interface. It's kind of repetition, but it is something we inherited. This is why we have an I in there. I read it in a book somewhere. I really cannot recall what is the name of the book, but it's a fun thing to know. So this is the part about interfaces. This I already covered is and as, I think, when I was costing things here. So these are like the gist of the stuff which I wanted to talk about when it comes to that part which Dennis actually have covered regarding the iLoggers and iCustomers or iStudents and so on and so forth. Now you have like two sides of, like not two sides of the story, but you have two different examples, almost completely different examples on how to utilize interfaces and why they are super powerful to work with. Any questions before I move on to Windows Forms? Okay, I'll take the silence as a no. So Is this clear, by the way? Is it actually good? Is it like everybody? Is everybody okay with this?
Yes, it's okay.
All right. Okay, so moving along. I will actually create a new project right here, which is going to be a Windows Forms .NET Framework, Windows. Okay, so if I actually go here, you have many of them. So desktop, I'm choosing actually this one, not this, but this. Okay, and I'll call this intro to Windows Forms. Okay, so Windows Forms. One of the things that you have to know about Windows Forms, they are native to Windows. They are not cross-platforms. They're not cross-platform. Microsoft has this UWP, which was trying to push as a cross-platform at a certain point in time, I think. But right now we have Xamarin to do that. So let me actually mention a couple of things here. Your operating system has several layers of like pieces of let's say of well, how would I say software, like not regions, but several layers, architectural layers, where you have, for example, the kernel, where you have a lot of interesting interaction going on with the CPU and memory and drivers and stuff like that. You have the also the process management, task management, and all that stuff, which comes into the package. You have also something which is called the shell, which is the visual part of your operating system, the thing which sits on top of all that stuff. Now, the shell is native to every operating system. So, for example, Windows shell is completely different in terms of code base than Mac's, than Linux's shell, which has many of them. You have the KDE, XFCE, and GNOME, and other famous ones that and other things that you might maybe remember. Now, why I'm mentioning this is because like each one of these operating systems, their shells offer something which is called APIs, which is Application Programming Interface, which probably have integrated with web, web Raspberry design. I think it's called the type treatment. So web development and design, I think, yeah. So where you had actually like you were triggering, you were talking to a JavaScript, like you were calling a JavaScript API that gives you data. I think in the first year, you guys already have tried that. Now, an API is just simply abstraction. So it abstracts a very complicated piece of code to do a very simple interaction. So for example, if I would like to click on a button, that handling of the mouse moving and the drivers finding out which button did you click on which mouse and which button did you click in the window, whether it was this window or another window, this full stack of calls and complicated loops within the operating system to figure out where did you click is already handled by the operating system, and it just exposes to you one just tiny event which says you clicked on a button, right? And this is called the API of the shell, right? Now, Windows Forms is utilizing, I think, what was called Win32 API, which is alive with us since, I don't know, Windows 95 or 98 days, and it never gone away. Microsoft tried to get rid of it and couldn't. That's why they introduced the UWP and WPF and all that stuff, and still, and probably still, I mean, WPF is something else, but UWP they tried to introduce and they probably couldn't until now. I don't know. So what happens if I would like to run this same program onto other platforms, right? And right now it comes to the point where you need to choose another framework, you need to choose another software, like another stack. because not every shell has the same APIs. Now, right now, you jump into the problem of right now when you find a framework, it's going to be more like a JavaScript framework or other translation frameworks, like for example, you have the Flutter, you have Electron, you have all these guys where you can actually write in JavaScript code and then it runs everywhere. The interesting part here is it doesn't run everywhere for free. You have a translation layer within these frameworks, which translates your calls to the native shell, right? So you have an engine that runs specifically on Windows, runs specifically on Mac, and runs specifically on Linux. And this is why it runs everywhere. It's not people being just like, say, hey, Microsoft is not that smart enough. It is actually smart enough. It just, people have to write an engine to translate these calls to its native shell like counterparts. So for example, if you click on a button in Windows, it will trigger a series of events and a series of calls within the operating system that's completely different from Mac, right? And people who written this in JavaScript, for example, or whatever programming language, they have as well this translation layer. If you are in the C++ world, I think you could have heard of Qt, for example. And Qt has this abstraction layer, which works on Mac, on Windows, on Linux, for example, right? So it handles all that for you. So you don't need to write the complicated code for every platform. So I think Microsoft has introduced, I think Xamarin is the one which Microsoft has given to us, that you could actually write code that runs everywhere, but you run it, like you write it once and it runs everywhere. And Microsoft written this translation layer for, I don't know, for Android, for iOS, and for other operating systems. So you don't need to write code specifically for every platform. That's being said, let's talk more about the creation of forms themselves. This form, which you see here in C++, I think it will cost you like 50 lines of code, 30 lines of code, or something like that. There's a lot of details going on. You need to draw the form. You need to put the buttons in place. You need to define the boundaries. You need to register it in the operating system loop and make it registerable that it actually appears right here in the bottom, right in the taskbar. There are a lot of stuff going on there just to get a form on, by the way. It's not that very simple code. However, Microsoft was kind enough that just simply said, you know, when you run a program, you just create a new object of a form and bam, it's just there, right? It registers in the operating system. It just does everything for you. Like you get the drawing done. All what you need to do, just write the code, right? So let's talk about, when I was talking about the Windows API bit, if you take a button and you hit F4, F4 is for properties, by the way, you get all the properties which are corresponding to that button. This is the stuff which is exposed by Windows to us. There's even more, but it's maybe hidden in code that you need to dig in Windows APIs, documentation, and you can actually trigger them. So there are more stuff than here. Maybe. I mean, I didn't look at the documentation, API documentation of a button, to be honest. But I'm sure, like, I've seen already many people doing crazy stuff with buttons that I couldn't even imagine they would do. So they were like, you know, but they are using properties that are not even mentioned here. So they were addressing certain native Windows API stuff that can only run on Windows just to pull out some certain effects. Now, a button has a text, which is a text property right here. We have a name, obviously. Now, we usually, when naming controls in Windows, we usually use something which is called the Hungarian notation. So we say btn and then the name of the button. So for example, I'm going to call this random right now. Okay. So because I'm going to make this button jump randomly around the form. So this is what we call the Hungarian notation. It's quite popular in Windows forms. And this is, I think, the only place where we do that. And a Hungarian notation means that you make an acronym of the type of the object and then the name of the object. And I think it was also popular in C++ days in the old C++ days where the IDEs never told you what the type was. But right now, for example, in Windows, maybe in Windows Forms, maybe it is needed because it's easier to find controls that way. So you will find it in production. Even some people like use this Hungarian notation. And here I'm just going to put the text to random. Now, obviously, since all of these properties are here, obviously I can access them from code. So if I actually take a button and double click, if I double click, it will trigger any control you double click it, it will trigger the default action for it. So for example, a text box like this has, I think on double click, it should be actually on text changed. There you go. So on text changed. Okay. So this is like, depending on the default stuff, which usually people look for, it will handle the event by default when you double click it. Okay. Now I will actually address a couple of things here first. Most of the students, what I've seen have done is that they don't realize that this is a partial class. And what they do, they just simply erase this thing. And then you get an error, right? And I've seen this, even people having this in the exams, and sometimes they actually get stuck. Please remember that this form is a partial class. And a partial class means that this class is split into two files, and it is literally merged on compilation. Like this file and this file become one when you compile it, okay? Now, obviously, we have a problem here because this guy is pointing to a function. It's a delegate. It's pointing to a function that doesn't exist, a function pointer. So just simply like remove this, and we are back to normal. I'll just simply remove this for now. Okay. So a partial class. This was actually introduced in C# 2.0, by the way. It didn't exist in C# 1. So when I first started with Windows Forms, in fact, the code here, where is it? The code here was like, I mean, this whole thing was actually all here. So if you had a complicated form, we had like what? You could have a Windows form that was like 1,000 lines of code. And then when they actually introduced in C# 2.0 partial classes, they just simply split the file. So a file split here and a file split there, and you are good to go. Now let's see. If I actually hit F4 again and I look at the properties, you have this location property, which is actually in, it's not in pixels, just to be clear here. It's in points, I think, and a specific metric to the operating system. So here I can have, say, the btn random dot location equals to new point. And right now, because location is actually of a point class, right? And I can give it x and y, so I can say 200 and 200. Okay. And if I hit Control F5, and if I press the button, right now it just jumped here. Okay. And obviously, when I click it again, nothing happens. So what I could do is I can have a random equals to new random. And I can say random dot, actually, how about this? I can say random dot next. And I can actually type in what integers I would like to have. So I would like to say, okay, please give me a random number between, I don't know, 100 and 300. And the same thing for this guy, 100, 300. I'm just going to move this guy up. Okay. Outside of the function. So just keep it there. Maybe even, yeah, I'll just keep it there for now. And I hit Control 5. So if I click here, right now my button is just simply jumping randomly everywhere. Now here's the interesting part. I could actually utilize the properties of this window So right now here we have a property. It has, for example, something which is called the size, and I can utilize that size. So I can say, for example, random between 0, for example, and this dot size dot width, for example, and this is going to be 0. This dot size dot height, for example, maybe minus 50. Maybe here also minus 50, just for fun. There we go. Okay. And right now, I will have a button that jumps everywhere in a form, regardless of its size. Right. So if I actually click here, oh, there it is. Click there. If I make it smaller, oh, there it is. I can just simply like make it jump anywhere. Okay. Actually, a student in one generation made the Frogger game in Windows Forms in that way. I don't know if you have seen this game before. Here it is. Like the frog which crosses the road. So you have a small frog and you need to cross the road. You need to cross it until safety. A girl actually made that game, but instead of course, without graphics, she made it with buttons. And literally the buttons were rushing like to the side, moving to the side, and we had a small button that we were moving with keyboard upwards. So it actually was interesting. Was very, very interesting project, I have to say. I'm gonna actually go without a break here because right now, like I gave the students this that they experiment with. So they actually like start clicking on a button, just make the thing go random around. Okay. And what I given them later was, and also I implore you that you actually try this at home. You need to try this. So I'm not actually going to solve it right now. I'm going to actually solve it in the next class. So this is like considered as a homework because you need to try this. And you need to, as an engineer, you need to execute whatever you want and see it happening. So I gave them I gave them the task to make a calculator. So how to make a calculator, right? So the thing here is if you look at a calculator in Windows, so calculator. Right now, what I said is like, I'm actually going to take a screenshot right here really quick so I can paint. So I actually said I don't care about these, okay? So I'm gonna paint this thing in black. Or actually, you know what? Black. So I actually don't care about this. Or really now. Doesn't matter. It's gonna be white today. So I don't care about this. I don't care about that. Honestly, I don't care about this either. Right? So I didn't care about any of that stuff. What I care about, however, is that you get this layout. Now, obviously, you might need to move things around. So for example, maybe this will move up. Maybe this will actually like expand like so, like crazy. I don't know. It's really up to you right now how you're gonna lay out the thing. Maybe you will actually like move things a little bit down here and maybe like take this guy and actually this is your header of your form. So you don't have anything in there. So right now this is your form practically speaking. Okay, so there we go. Right, so this is basically quote unquote your calculator. Okay, so maybe even you can, I mean, I don't care about this even. If you want to have it, just have it. It's okay. Now, one of the things which you need to care about is that you don't need to make, I don't want you to make the functionality to be like parsing the equation. So if, for example, some people say, so So they say, for example, 1 plus 2 plus 3 plus 4. If you notice, I don't actually write in a complete string of 1 plus 2 plus 3 plus 4, but actually it keeps adding up correctly. So 1 plus 2, when I hit the plus, it immediately summed that up, right? You don't need to write this right now. You can implement this as a bonus, but you don't need this right now. What you need to do is to make sure that this is working. Now, I think you already have made this working in console application, I think. So in Windows Forms, you have a different challenge, right? You don't have this console input. You don't say, I need this operation, and then you do this. I need this operation, and you do that. But you literally click, and then you choose the operation, and it will just simply work. Now, the 2 points which we need to hit on, why you have this kind of training. One, you need to be able to control the properties of the controls. You need to know how can I make these buttons big? How can I make these numbers big? How can I make this text box as big as it is? And how can I make this text going from right to left instead of left to right? Yeah. How, for example, how to handle button events on click for these guys, right? What happens if I click 0? What happens if I click 1, 2, and 3, right? So, for example, right now, I'm just simply talking to you about the problems which you're facing. This right now is 0. However, if I hit 3, it immediately transforms to 3. It doesn't become 0, 3. It just simply replaces it with 3, right? So if I actually put 0 in there right now, it works. So if I hit backspace all the way, there's nothing in there. It will just simply have 0. Okay. This is what I was actually forcing the students to do. They were trying to get this look right. So once you actually be able to get this look right, you are comfortable on controlling what you want to display here. So right now, you know how okay, I would like to display that button in that size, in that position, right? You would like to make the colors that better, and so on and so forth. This right now is up to you, okay? There's one tip I will give to you, which I also have seen people having. When you have 10 buttons, you can make all these 10 buttons look to one event, by the way. They can handle one single event. So you don't have 10 buttons doing 10 similar things. You can have one button doing only one event. Many buttons doing the same event. But maybe we can discuss this probably next time. So my task for you actually is, until we meet next time, is that you actually implement that calculator, okay? And before we start the class, I'm gonna ask you to show me what you have done so far and show me how you implemented things. And I will actually show you, like, not the complete calculator, but I will show you how to handle things in a better way if you actually haven't yet. Please do not try to parse equations, or parse mathematical expressions. Do not try to do that. It is not the requirement. If you do it, then fine. If not, please do not try to do that. It's not the task. And if you would like to parse mathematical equation, usually we parse it into a tree, by the way. So because I've seen students who are trying to do this. So for example, they were trying to do something like this: 1 plus 2 plus 3 minus 4. And they would like to calculate this all at once. So they were trying to split the strings based on these characters, but then they need to make the operations right. The idea here is this needs to be broken down into a tree. So and this we will study in algorithms and data structures, where you can do something like this. So this is 1 plus 2, for example, okay? And this is in a node, right? Oh, sorry, 1 plus 2. So, sorry, hang on. 1, 2, and this is the plus sign. And this is the tree here. And then you have another one, which is going to be 3. Sorry, let me just make this better. So you have a plus here, which is going to be 3. And then you have somewhere there minus, 4. Something similar to this. Okay, so you're gonna have to break down your mathematical expression into a tree, and then you resolve it. Okay, this is one of the easier way of doing it. Maybe there's not maybe there's surely maybe other ways of making this better, but I'm showing you like what should happen if you go that route. So instead of doing this, like parsing mathematical expressions into trees, just simply say for example, you press 1, then you say plus, and then you keep the last operation which you made. So for example, this is the plus, and then you say 2, right? And then you say minus. The moment you say minus, you say, aha, okay, the last operation was plus, I will add 1 and the 2, because 1 I kept it in a buffer, or I kept it somewhere temporarily. I will add the 1 and the 2, I'll make this 3, right? It becomes 3. And then I will keep the minus as the last operation has been made. And then I say, for example, 6, right? And then we say, when you hit the 6, and then you say, for example, plus, right now the sign has changed, or the operation has changed. You actually take the last operation, you take whatever was in the buffer, which was 3, and then you negate it with 6, or minus 6, and then you get like, I don't know what, minus 3. And then you have this plus, right? Is the last thing you pressed. You press, for example, again 3. Once you press 3, and you say, for example, equal, it will take whatever minus 3 was in the buffer, plus 3, which was there, and should give you actually 0, for instance. Okay? You see how I went step by step? I didn't go say, give me this all at once. It's actually happening like this kind of step by step. The same like your regular calculator, the cheap, small calculator, not the crazy new kind of, no, smart, let's say, calculators, okay? So it's very, very important to get. All right. Do you guys have any questions regarding this task? Hang on, let me, actually, I'm done with this part, so let me stop recording.